So I'm going to talk about the vertex form for a quadratic. And this is an interesting way to think about a quadratic. So let's just go over some of the other forms. There's standard form for a quadratic, and that's y equals ax squared plus bx plus c. And from this form, we can find the axis of symmetry, which is a line, x equals negative b over 2a. Something that we kind of commit to memory, although this is part of the quadratic formula. And then we can find the vertex. Ooh, vertex. I did just say vertex, which is what we're going to go for here. And then the vertex is we use this x value to find out the y value, and that's going to give us our maximum value. Maximum value or minimum, maximum or minimum always happens on the axis of symmetry. So we can find our vertex, and we just need the y value that goes with the x equals negative b over 2a, right? And that would give us our value. For right now, I'm just going to call this x value, I'm going to call it h, for a reason that will be clear in a moment, I hope. And this y value, I'm going to call it k. So there's my hk. So our vertex would be the point. So our vertex would be the point h comma k. And there's other forms of quadratics. If we were to factor this and find the roots of the quadratic, that's another way to represent a quadratic. But right now we're just thinking about this form right here. I'll just make that yellow. So what is vertex form? Vertex form for a quadratic is just like let me write this down. Let's see. There's root form. For a quadratic, that's y is equal to let's say some number a in front, x minus, usually we use a different one, p, and x minus q, and the roots, right, are when the graph passes through the x-axis, which is also when y is equal to 0. We solved a lot of quadratics when this is equal to 0 only when x is equal to p or x is equal to q, and the roots would be at the point p comma 0 and q comma 0. So just like root form would give us these it would give us these roots, real easy to see where the graph of the parabola passed through the x-axis, and then we could graph it pretty easily. And this right here would give us an axis of symmetry. We would start by that, right? We'd start with the axis of symmetry. We'd find the vertex, which is h comma k. We could also get the y-intercept, which is at x equals 0. Y is c, right? So we would get a c value here, and we have a vertex. Let me put that in red. We would then be able to sketch our quadratic here. And maybe with our table of values, we would find out where these roots are, or we could go back and factor. So these are all things that we've done before, and now I want to get rid of that big blue thing and talk about vertex form for a quadratic. Vertex form is when you have a quadratic in the form y is equal to some number a times x minus h squared plus k. And the vertex here, the vertex would be at the point h comma k. What drives this vertex form? Maybe you've seen this, something similar to this form earlier, and it could be in absolute values. So when you looked at an absolute value, let's just put an absolute value. Y is equal to, let's say, a absolute value of x minus h, close absolute value, plus k. You may have seen this before, in that this is an absolute value, right? Let's suppose a is positive for a second. This is an absolute value whose in this case it would be a minimum value, would be at the point h comma k. This is so the positive a value. And you probably saw as you change the h value up and down, that would shift in this graph. So h changing up and down would shift this graph left and right, and k, moving k up and down, would shift this graph also up and down, shift this vertex up and down. So hopefully you saw that. But getting the quadratic into vertex form is very straightforward. You should always check to make sure that with foiling to make sure that this is what I'm about to show you is correct. But if you have something in standard form, or you get it into standard form, and you find the axis of symmetry, and you find this h and this k, the way to put it into this form is you take the coefficient for x and pull it out. So let me do an example. Y is equal to negative 2x squared plus 4x minus 1. So here's my a value. I left it as an a value on purpose. To get it into vertex form, y is equal to, just take that a value, let me do it in orange, take that a value, put it out front, minus 2, make your parentheses, don't forget your squared, okay, and then we're going to put a plus here for now. This number might be negative, and then just use your h and your k you found right over here from your standard form. It would be x minus, let's find our h and k. So our axis of symmetry, which always has our vertex, is x is equal to negative b, is our opposite of b, so it would be negative 4 over 2 times a, which is 2 times negative 2. So this is equal to 1. So there's our h. And what about our k? Our k is the y value associated with this. So y evaluated at 1. That's negative 2 times 1. So let me write that up here. Negative 2 times 1 squared plus 4 times 1 minus 1. What is that? That's negative 2 plus 4 minus 1. That's equal to 1. So there's my k. So there I have my h and my k. So I'm just going to put it right into this formula here. X minus 1 plus 1. And that's it. This is your vertex form. We always should FOIL to make sure we would go from this to this. We should FOIL this out. Let's do that. I'll do that if I have time here right now. This, leave that 2 out there. We have x squared minus 2x plus 1. That's just FOILing out this term. Check it. And then we still have this plus 1 on the outside. Plus 1. Oh, I forgot my negative 2. Distribute this negative 2 over each term. We get negative 2x squared plus 4x minus 2 plus 1. And this negative 2 and plus 1 are the only like terms here. So we get negative 2x squared plus 4x minus 1. Exactly what we started with. So check and mate.